Hello, this is a video to help you review for the Chapter 4 test in Intermediate Algebra. And first of all, let's look at an example like what you might have in problem 1 on the test. It says 3x minus 38 is less than negative 2 times parentheses x plus 4, close parentheses. So first of all, you have to distribute this negative 2, so you'll get negative 2x, and you'll get negative 8. Then you'll have that sign, then on the other side you'll have 3x minus 38. Now, I'm going to add 2x to both sides, because that's the smaller of the two quantities of x. Then I'll get 5x minus 38 less than negative 8, because the negative 2x plus 2x goes away. Then I'm going to add 38 to both sides, and I'll be left with 30 on the right side and 5x on the left side. Then I'll divide by 5. Now, if you ever divide by a negative in an inequality, then remember to switch the direction of the inequality. But in this case, since I'm dividing by a positive number, I do not need to switch the inequality, so this will stay a less than sign. But if I would have divided it by a negative number, I would have changed that less than sign to a greater than sign. So keep that in mind in case that might happen on your test. So I have now solved it. The solution is x is less than 6. However, though, that's just a math formula. I need to change that into an answer that represents the actual numbers. So let me actually draw a graph real quick of what that means. So if you put 6 on a number line, and then you actually put an open circle at 6 because 6 is not included, and then less than 6 would be shading to the left of 6, and it goes all the way to negative infinity, so I'll put an arrow at the left end of that. And then I'll also put a parenthesis right there to show that 6 itself is not quite included in the answer. Now, looking at that graph, that's actually the answer to part of this problem. So you should choose for the answer to the second part of this problem, a graph of a number line that looks like that. But the answer to the first part of the problem is actually based on that same concept. So looking at that solution, x is less than 6, that means you can go all the way to negative infinity and then all the way to 6, but not including 6. So remember, a parenthesis means it's not actually included. So the solution to the first part of the problem is this answer that I just boxed in. The solution to the second part of the problem is this answer. So that's to help you with problem number 1. Now let's try problem number 2. So company A, it says, is equal to $90 per day plus 20 cents per mile, which I'm going to say X is the number of miles. And then company B charges $60 a day plus 70 cents per mile. And what we want to know is, when does company A have a better deal? So when does company A cost less than company B? So when is A less than B? Well, so to solve that, I'll just do 90 plus 0.20x is a better deal, or less than $60 plus 0.70x. Then I'll subtract the x, which is smaller, which is this one. So 0.020x minus 0.20x. Then on the left side, I'll get 90. Then that'll go away. So 90 is less than 60 plus 0.50x. Then I'll subtract 60 from both sides. Then I'll be left with 30 is less than 0.50x. Then, if I wanted to, there's actually two things I could do. I could multiply both sides by 2, because 2 times 0.5 would just be 1 and it would cancel it out. Or I could divide by 0.50. So I'm going to do that. In general, you might have to divide. In this case, you could multiply or divide. Either one would work. But I'm going to divide since that's usually going to happen more often. So 30 divided by 0.50 is 60. So 60 is less, and then this crosses out, so you're left with just x. So 60 is less than x. So the answer to the problem is the truck has to be driven more, because see, 60 is less than x, so that means x is more than 60. So the truck must be driven more than 60 miles per day, more than 60 miles per day, in order for it to be a better deal for company A. So that's how you do problem 2. Now let's try something like problem 3. So problem 3 says 1, 3, 5, 8, 9 intersected with, or just intersection, that symbol means intersection. So what's the intersection of 1, 3, 5, 8, 9 and 1, 5, 7, 9? So this symbol right here means what's in common. What's in common between them? What's in common? So what's in common between those two sets is called the intersection of those two sets, and it would be the number 1, 5, and 9. So the answer to this problem would be 1, 5, and 9. Now I'm not sure, in your problem it might have those brackets, those curly brackets already typed. So you might only have to type in just the numbers with commas between them. But if they don't already have the brackets typed, then you might have to actually type in those brackets as well. So I'm not sure whether you'll have to type in just the numbers if they have the brackets already, or if they don't have the brackets already, then you'll have to type in those curly brackets and then the numbers in them with commas between them. So one way or the other, there should be brackets around the answer, but the test online might have those brackets already there for you. Okay, let's try something like number 4. So x minus 5 is less than or equal to 3, and 3x plus 2 is greater than negative 13. So if I solve this, I'll add 5 to both sides. X is less than or equal to 8. So then I'll get 3x is greater than negative 15. Then I'll divide by 3. X is greater than negative 5. So if I draw this number line and this number line, so first of all, if I graph the solution of the first problem, it says x is less than or equal to 8. So you'll have 8, and it's its true solution, so there's an actual dot there, and x is less than or equal to it. So you'll also shade less than 8, and then you'll put a bracket on the 8, because the bracket symbolizes that it does include 8, because it could be less than or equal to 8. So that's the graph of that solution. Then we'll graph the other solution. So by the way, it does want a graph of that solution. So one of your answers is going to be that. And then this one, x is greater than negative 5. So you'll have negative 5 on the graph. And it doesn't actually equal that point, but it could be greater than that point. So you'll shade towards the right, because that means greater than negative 5. And then you'll also put a parenthesis right there as well. So that's the solution that represents the answer to the second inequality. Now, what does it mean when it says graph the compound equality, this one and that one? Well, we just learned the word intersection means in common. Well, the word and also means in common. So what is in common between those two graphs? Well, notice one graph is everything less than or equal to 8. The other graph is everything greater than negative 5. So what's in common between them? What is in common between them? Well, that would be the graph that is everything greater than negative 5, right? Like this. but also has to be also is less than or equal to 8. So between those two numbers is the part that's in common between both of those graphs. Because these numbers that I'm shading, those numbers are actually part of both of the previous solutions. So this number is the graph. I mean, this graph is the graph of the solution to both of them together at once, the part that's in common. So that's the solution to one inequality and the other inequality at the same time. And so the solution in interval notation would be just simply a parenthesis and then -5, 8, and with a bracket like that. So there we go. And then problem 5, let's try something like that. So 5 says -11 is less than or equal to 2x over 3 minus 13 less than -5. So my first step is going to be to add 13 to all three sides of this problem. So on this problem, there's actually 3 different sides. So there we go. We'll have 2 less than or equal to 2x over 3 less than -5 plus 13 would be +8. Now we have to get the x by itself, so notice that there's a denominator that's below the x of 3. So I need to multiply all 3 sides of this equation times 3, which is the least common denominator. So then I'll get 6 is less than or equal to, now on this one the 3 goes away. So we're just left with 2x, and the fraction has been cleared. 3 times 8 is 24. Then we get this, and then we still need to get the x by itself, so I need to divide all 3 sides by 2. So then we'll have 3 is less than or equal to x is less than 12. So then the solution would be that it could equal 3, or it could be less than 12. So on 3 there's a bracket, and on 12 there's a parenthesis. So that's the solution to the inequality. But then we can also graph the inequality. So we'll start from 3. There is a point at 3. And then we'll go to 12. There's not actually a point at 12 because it doesn't equal 12. But everything between 3 and 12 is included in the answer. And there's a bracket, therefore, on the 3 and a parenthesis, therefore, on the 12. So that's the graph of that solution on a number line. Now, let's try problem 6. So if A set A equals 4, 5, 7, 8, 9, and if set B equals 0, 1, 3, 6, then it says find the set A union B. So that symbol right there means union. And union, so remember intersection before. Intersection means what's in common. Union means combine all of them from either one of the sets all together. So everybody in either one of those sets is going to be included, every number or every element. So A union B would be, well, let's start from the lowest. So 0, 1, 0, 1, 3, 4, 5, 6, 7, 8, 9. So if I take every number from either one of those sets and if I include them all, the only thing that's not in either one of the sets is 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it goes all the way to 9. So 0, 1, 3, and then all the way to 9. Every integer from 3 to 9 is included. So that's the union of those two sets. Now, a union cannot include something that was not in any of the original sets. So I cannot put 2 into the union because 2 is not in either one of the sets at first. But a union does include everything that was in either one of the original sets. It includes all of it. So that's the answer to that problem. All right, now let's try problem 7. So let's clear that. Try problem something like 7. 3x plus 2 less than or equal to 5, or 5x minus 8 greater than or equal to 12. So if I solve this one, I'll subtract 2 from both sides. Then I'll get 3x less than or equal to 3, divide by 3 on both sides. I'll get x is less than or equal to 1. Then I'll solve the other equation by adding 8 to both sides. So then I've got 5x greater than or equal to 20. Divide by 5. X is greater than or equal to 4. And so if I graph the first solution, x is less than or equal to 1, you'd have 1. And it could be less than 1 as well. So if it could be less than or equal to 1, it could be anything all the way to negative infinity, and then all the way up to 1 itself. So that would be the graph of x is less than or equal to 1. And then the graph of x is greater than or equal to 4, you'd have 4 on the graph, and it'd be solid. Oh, actually, I forgot. Hold on. In the previous graph, there would also be a bracket at 1 as well, because 1 is included in the answer. Okay, then on this graph, you have x is greater than or equal to 4. So it could be greater than 4, so you'd shade towards the right, and there'd be a bracket at 4 because 4 is included. And the bracket always points towards the side that's shaded. Then that would be the answer to that one. Okay, now you might be wondering, what about the graph of them both together? So here's the key thing. The word or actually means union. So if it said and, that would be intersection. And the intersection would be the numbers that are in common, but there wouldn't be any numbers in common that are less than or equal to 1 and that are also greater than or equal to 4. So it would be impossible to have any solution to that. But it is possible to have a solution to the union, because union means or. Union just means put all of the sides, both of the numbers from all the sides together. So all of the numbers from both of the sides together. So the union of those two graphs would actually look like one number line that includes all of those shaded parts. So it would include 1 all the way to negative infinity, that would be shaded. And then the union would also include this side from 4 to infinity. So when you do a union, it can sort of add two different parts of the solution together. So that would be the graph of the union of the compound inequality, meaning the both of the inequalities at once. So the solution set for the whole thing at once in the interval notation, it would just be what you see in that combined graph. So it would be, hold on, let me erase this, make that a little smaller. So the solution to the union would be negative infinity through 1 bracket union, because remember union means you're going to add something else onto it, union bracket 4 comma infinity parenthesis. Now the reason infinity always has a parenthesis is because you can't actually touch infinity. So you can never really include infinity in the answer, so infinity has a parenthesis beside it. So that's how you do something like problem number 7. Now let's try something like problem number 8. So this one says negative 2x plus 5 greater than 9, or negative 2x plus 18 greater than 4x. So if I solve this one, I will subtract 5 from both sides. So we get negative 2x is greater than positive 4. And then I'll divide both sides by negative 2. Now, just a second, do you remember what I said to do a few minutes ago? Whenever you divide or multiply an inequality by a negative number, you have to switch the inequality. So that's going to become x, because the negative 2's will cross out. But then this inequality, though, is going to become the opposite. It's going to become less than, because we divided it by a negative. And then 4 divided by negative 2 is negative 2. So that solution looks like this. X is less than negative 2. So it's like that. X is less than negative 2. Then we'll do the other one. So if I solve this problem, I will subtract the 4x from both sides. Then I'll get negative 6x plus 18 greater than 0. Then I'll subtract 18 from both sides. Negative 6x greater than negative 18. Then again, I'll have to divide by a negative number. So you'll get x, but now you'll get greater than, no, I'm sorry, it'll switch directions. So you'll get less than, and then this would be positive 3. So it says x is less than positive 3. So you'll have positive 3 on the graph, and you'll be shading the numbers, or the numbers that are less than 3, so shade to the left. So that graph will look like that. And then I forgot the parenthesis that's on both graphs, because negative 2 is not included, and also 3 is not included either. So everything that's less than 3 is included. Now, those are the graphs of the two separate parts of the problem. So what's the graph of the combined compound inequality with the word or? So the word or means you put all of the numbers together. So we're going to take all of the numbers that are less than negative 2 and all of the numbers that are less than 3. So first of all, if I draw a number line and I put all the numbers that are less than negative 2 on the number line, then I would go all the way up to negative 2, right? But then I'm also going to put on all the numbers that are less than 3. So I have to keep on going. I keep on going to the numbers that are less than 3 until I get to 3. Now notice, the numbers that are less than 3 go past the numbers that are less than negative 2. But that's fine though, because when you do the word or, that means union, which means you're going to include all those numbers together. You're not going to leave any of them out. So we're going to include all of those numbers. So this new graph actually goes not all the way just to negative 2. It goes all the way up to 3. 3 is not included though. So there's no actual point at 3 because it still says x has to be less than 3. So that's and then let me add the parenthesis. So that's the graph of the combined solution. Now notice, since the shaded areas are all together with no gap and no hole in between them at all, that means that this answer is actually, there's only one part of the answer. It goes all the way from negative infinity on the left. So let me draw a box around that. So that union, the combined answer, it really goes all the way from negative infinity through 3. But it's not, you don't actually stop until you get to 3. So that answer would be the combined answer, just from negative infinity to 3, with parentheses on both sides. Now let's try problem number 9. So problem number 9 says x minus 4 equals absolute value, the absolute value of x minus 4 equals 7. Now, what that means is the absolute value means that what is inside of it could actually be a positive or a negative. But because when you take the absolute value of a positive or a negative, you'll only get a positive, right? So really, this means that this number that's inside, that number inside, it could actually be a positive 7 or a negative 7, right? Because the absolute value of positive or negative 7 is equal to 7. So there's a principle of absolute values. If you have anything, I'll just say A for anything, equal to a positive number, like that, if the absolute value of anything equals a positive number, then that means that the value of the number, anything that was inside, could be a positive or a negative number. So all you have to do to take the absolute values off is to change the number to be a positive or a negative. And then you take away the absolute values. So we're going to do that. So in this case, the anything that we have is x minus 4. So this means x minus 4 equals positive or negative 7. Then I'm going to add 4 to both sides. So, or in other words, I'll move this negative 4 over to that side. It's better to think of it that way in this problem because it's a little bit more complicated. So if I move a negative 4 to the right side, then it'll become positive 4. But you'll still have the positive or negative 7. So you'll have x equals 4 plus or minus 7. So then x equals 4 plus 7, which would be 11. Or it could be 4 minus 7, which would be negative 3. So there's two answers to the problem. Oh wait, I think I made a mistake. Hold on. No, this is good. So there's two answers to the problem, which are 11 and negative 3. So that's how you solve the problem. Okay, then let's try problem 10. So 7x minus 2 absolute value equals 3x plus 15 absolute value. So this problem looks more complicated because there's absolute values around both of the sides. But don't worry though, because even though the left side could be positive and the right side could be negative, or the right side could be positive or the left side could be negative, no matter which combination it is, really it could just either be positive or negative. That's still the bottom line. So what you can do is you can just drop off the absolute values from the left side and also drop off the absolute values from the right side. However though, remember, you have to change the right side to be plus or minus. So we're going to change it to be positive. So positive 3x plus 15. Or, now in this case, since it's a bigger equation, we should probably do this as a separate problem. So if I wanted to, I could just say 7x minus 2 equals positive or negative 3x plus 15. But that would get kind of complicated. So instead of saying positive or negative, I'm just going to say or, and then I'll say 7x minus 2 equals negative 3x plus 15. So that makes it a lot easier to keep track of. So I'm going to divide those two equations into two different problems. So if the first equation is true, then really you just have 7x minus 2 equals 3x plus 15. That's really just what it means. So then I'll subtract 3x from both sides, and then I'll get 4x minus 2 equals 15. Then I'll add 2 to both sides. So if 4x equals 17, and then I'll divide both sides by 4. So the x will equal 17 over 4. Now the other equation, I also solve it, but now I have to distribute this negative though. So if I distribute the negative, I'll get negative 3x minus 15 equals 7x minus 2. So then I'll add 3x to both sides, and then I'll get 10x minus 2 equals negative 15. And then I'll add 2 to both sides, and then I'll get 10x equals negative 13. Then I'll divide by 10, and I'll get x equals negative 13 over 10. So there we go. Now the thing is, those two answers are both solutions to the problem. It could be one of them or the other one of them. So the final solution is really both of them together. So 17 fourths, comma, negative 13 tenths. So the final solution is actually both of them at once. So that's the final solution. Okay, now let's go to an inequality that also has an absolute value. So let's try problem number 11. So number 11 looks like this. 2x minus 7, absolute value is less than 3. So when an absolute value is less than 3, it actually technically means that it's between -3 to +3. Because it basically means it's a number that could be positive or negative, but it has to be smaller than either a, well, it has to be littler, in other words, littler in value, in absolute value, than 3 or -3. So that means it's between, so 2x minus 7 has to therefore be between -3 and +3. So it's somewhere between them. So the principle of this is, if the absolute value of anything is less than a positive number, then the way to solve it is it means it's between that negative number of anything and less than the positive number of that number. So that's that's the principle that you use to solve this problem. Then I'll add 7 to both sides, and I'll get 4 less than 2x less than 10. Then divide by 2 on all 3 sides. Then you'll get 2 is less than x is less than 5. And then you can also combine that together. It doesn't equal 2 and it doesn't equal 5, but it's between them. So the answer in interval notation would be from 2 to 5 with parentheses around them. And then the graph of it would just be 2 to 5 on a graph with shaded between them and then parentheses around those as well. So that would be how you'd solve problem number 11. And by the way, the name of this is called a conjunction. Conjunction. Because when you have an absolute value that's less than a positive number, that means it's combined sort of between them. It has to be between a negative and a positive number. Then let's try number 12. So number 12, instead of a conjunction, is a disjunction. So that says 7x minus 18 is greater than 17. Well, when you have the absolute value of anything greater than a positive number, then that means it's a big value. It could be a big absolute value that's a positive number, or a big absolute value of something that is a negative number. So if that anything in there happens to be a positive number, that means that anything could be bigger than that number. But if the anything is a big negative number, you see, being a big negative number would actually mean that you're something that is less than a negative number. Like -10, for example, is a big negative number, and that'd be less than like -1, right? So being a big absolute value, like greater than a number, absolute value greater than a number, that means you could be a big positive number, or you could be a big negative number. But big negative numbers are indicated by a less than sign. So and since those equations can't be written together, because you can't be bigger than something and less than something at the same time, that's not possible, right? Like you can't be bigger than 3 and less than 3 at the same time. So they have to be written separately. So they call this kind of problem a disjunction. So they call this a disjunction. And so we're going to apply that principle to this problem. So the absolute value of something greater than 17 means that that value of 7x minus 18 is greater than 17, or that thing inside 7x minus 18 is less than a -17, right? Because it's either greater than a positive number or less than a negative number. Now, I'll go ahead and add 18 to these equations. So if I do that, then I'll get 7x is greater than 35, and then I'll get 7x is less than +1. So then if I divide by 7, okay, x is greater than 5. And then if I divide by 7, I will get x is less than 1/7. And it's or, it still says or between them. Because remember, it's not possible to be bigger than 5 and less than 1/7 at the same time. So on a number, well, okay, so the solution set basically is, oh wait, let me graph the solution set first actually. So if I graph the solution set, it could be greater than 5, right? So it could be greater than 5, which is in that direction. Or it could be less than 1/7. Well, 1/7 is way over there. So it could be less than 1/7. Now, they can't happen at the same time, but that doesn't matter because it could be one or the other. So when you say or, then you can have two different things that are different from each other that both could happen. So that's, and then I'll put a parenthesis right here and a parenthesis right there. So that's the way that the solution looks. That means that for disjunction, there's going to be two parts of the answer. So it's going to be the final answer for the inequality is going to go from -infinity all the way to 1/7, right? So that would be this part. And then or, so the word union, the symbol union, or it also could go from 5 to +infinity, which would be this part. So the answer to this problem that goes in the first part of your answer is actually that answer right there. So that's the first part of your answer, but it actually helps you to see what the first answer will be if you draw the number line first, which the number line itself is the second part of your answer. Okay, good. Now let's try problem 13. So 13 says 3x minus y is less than or equal to 6. So the best way to do this is just to get y by itself. So I'm going to move the 3x to that side, which changes it to be -3x. So when you move a term to the opposite side of an equation or an inequality, it changes signs. Now the negative y, I need to divide it by a -1 underneath everything to change it to be a positive y. But do you remember what to do whenever you have an inequality and you divide it by a negative number? It changes the direction of the inequality. So instead of being less than or equal to, it will be greater than or equal to. Then you'll get +3x and you'll get -6. So whenever you divide by a negative number, it changes the sign. And that includes the inequality sign as well. So you get that. Now I'm ready to graph it. So do you remember how to graph a line? What you do when you graph a line is you start with the y-intercept. So on the y-axis, you're going to plot -6. And then you look at the slope. So the slope is 3, but you really can interpret that 3 as being 3/1. So you see 3, you go up 3. So go 1, 2, 3 up, and then over 1. And then you plot the next point. So the next point would be right there, up 3 and over 1. And then you should make sure that you graph a solid line. The reason it's a solid line is because that's a greater than or equal to. So if your inequality has an equals to in it, then it's a solid line. If it does not have an equals in it, then it's a dashed line. So we're going to draw a solid line going through those points like that. Now that's only part of the answer because we're not just drawing a line, we're also graphing an inequality. So we have to look at the direction of the inequality. Well, it says y is greater than or equal to that line. So greater than means up, right? So if you're talking about y, greater than would be up. But if you were talking about x, if it were x, then greater than would be towards the right. But in this case, it's talking about y. So y is greater than, that means you're going to go up above that line. So we're going to be shading above, which is upwards, right? Above that line. So we're going to shade, and you can click on the shading tool, click anywhere above that line, and it'll fill it all in everywhere above the line. It'll fill it in with, usually with yellow. Whoops, sorry, that part shouldn't be there. Whoops, hold on. I accidentally went across the line. So everywhere above the line is shaded with yellow. So there we go. That's how you graph that inequality. So let's try number 14. Number 14 is actually easier than number 13 because number 14 already has y by itself. So number 14, y is less than or equal to 3x plus 2. So once again, we're going to start with the 2. That's the y-intercept. So plot 2 on the y-axis. Then that 3 means 3 over 1. So we're going to, from that 2 where we were, we're going to go up 3 more, and then over 1, and then we're going to plot the next point. So that's the next point. So we're going to plot 2 on the y-intercept, then we're going to go up 3 over 1 and plot the next point. And then is it going to be a solid line or a dashed line? Well, because this says less than or equal to, it still says equal to in it, so it's going to be a solid line. So make sure your line is solid, and you can change it from solid to dashed or back to solid by using the type of a line button, which is next to the line graphing tool. So we're going to do a solid line through those 2 points, which, by the way, once you click the second point on the internet, it will draw the line for you automatically. So you just have to select the line tool, make it be a solid line, click on the first y-intercept and click on the second point, and then it will graph the line for you. Now, which way should I shade? Should I shade underneath the line or above the line? Well, this inequality says less than or equal to. So notice it says y is less than or equal to. Well, less than or equal to, and y means vertical. So if you shade in a vertical direction that's less than something, it would be below it. So we're going to shade below that line. So we're going to click on the shading tool on your graphing and on your graph and click below the line to shade everything below the line. Perfect. Now let's try number 15. So number 15 just says y is greater than, oops, just a second. Y is greater than -6. So you know this is a horizontal line because there's no x, so it's a horizontal line. So it's a horizontal line and its value is -6. So you're going to go to -6. So 1, 2, 3, 4, 5, 6. That's -6 right there. And you're going to plot a dot at -6. Now this is actually an open dot because instead of saying greater than -6, instead of saying greater than or equal to -6, it just says greater than -6. So -6 itself is not included. Now your graphing tool on the computer doesn't have an open dot, so don't worry about that. It's fine if you do a solid dot. However, though, you do need to make sure that your line is going to be dashed. So when you graph the line, make sure that it's dashed. So now you're going to move your line in a horizontal direction and make sure that it's dashed. So all you have to do is go to the right or left in a straight direction. So just if I go to the right, straight, and then I click another point. So click another point anywhere it's straight to the right or straight to the left, and make sure your line is dashed. So that's that graph. Now what we do is we think about, is it a greater or less? Well, this problem says y is greater. And if y is greater, that means it'd be above. So we're going to shade above that horizontal line. So we're going to click on the shading tool, and we're going to shade above that horizontal line, everywhere above that line. Perfect. Now, let's try. Oh, wow. That's actually the last problem. So I thought there might be a vertical line, but there's not. So, but just in case, I don't see anything else, any other topics covered on this test, but it's possible that you might have a vertical line. So I'm just going to do a question mark and put possibly there might be a problem like this. So the 16th example I'll show you, what if there's something like x is greater than negative 6, let's say. So what if instead of saying y is greater than negative 6, what if it said x is greater than negative 6? Well, if you have a line and there's only an x in the equation, then that means it's a vertical line. So what you're going to do is you're going to draw a vertical line at negative 6. Well, if it's vertical, that means it doesn't have a y-intercept of negative 6. It would have an x-intercept of negative 6. So you're going to go left, 1, 2, 3, 4, 5, 6. You're going to go left to negative 6. Then you're going to make an open dot because it doesn't say equal to negative 6. Then you're going to make a vertical dashed line. So you're going to make a vertical dashed line. So go straight up or straight down and then click another point and then make sure it's a dashed line and then the computer will graph it for you. And then it says x is greater than negative 6. So if you're talking about x, then greater than means towards the right. So if x is greater than something, then that means your x value is towards the right. So you're going to click then on the shading tool and you're going to shade anywhere on the right and then the computer will fill in the rest of it for you. So that's what you might have on your test, possibly. But it's probably just going to have a vertical line. All right, well, I hope this really helps you on your test and keep up your wonderful work and good luck to you and God bless.